Now I know a few of you are saying is like, all right, Willie, that was kind of cool. We're able to narrow down the search for the possible rational zeros. But I want more. I want to know which of those was a possible solution. So for you that are interested, let's look at this particular equation here. So first of all, can you determine what are the possible rational zeros? Can you narrow the search down? I'll do it too. Just want to make sure you kind of maybe a step ahead of me because we practiced this. It's all the factors of the constant term, which is a -6. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all over plus or minus 1. So there's all the solutions, possible solutions. And you can tell that there's 8, 1, 2, 3, 4. There's 8 possibilities that's a solution, that one of the rational solutions is found right there. So what do? Well, this is where we go back and remember our factor and remainder theorems. So let's try these as possible solutions. Now what this means, if this is a solution, so let's try 1. Remember that if 1 is a solution, then it's in the form of x minus 1. That means that x minus 1 is a factor of that term. And what we can do is we can use synthetic division to find out if 1 is a factor. Because if 1 is a factor, we'd have no remainder. So how do we do synthetic division? 1, 2, -5, and -6. Drop the 1. 1 times 1 is 1. Add 2. 1 times 2 is 2. Add. 1 times -3 is -3. Add. The remainder, when I chose x minus 1, 1 is a factor, my remainder was not 0. And remember, that's important, because if it was 0, then 1 would have been a solution. So I can cross off, out of these 8 solutions, I can cross off plus 1. That's no longer a possibility. All right, we just do it for the rest of them until we find one or get lucky. But remember again, even though we might have to do this process several times, we don't have to do it an infinite amount of time. And that's what I want to keep hitting home with you. So let's try 2. Same coefficients. 1, 2, -5, -6. Let me check to make sure I'm solving the problem right, or solving the problem I wrote. 1 times 2 is 2. Add. 2 times 4 is 8. Add 3. 2 times 3 is 6. I get a 0. Boom. So what that tells me then is that x minus 2, or x equals 2, is a rational root, or is a rational zero of this particular equation. Now there's a couple of more. I want to make sure I got them all. So what do I do with this? Remember, we can rewrite that equation now as f of x equals one of the factors, x minus 2, with the resulting factors, which I can get from these numbers right here. That tells me that's an x squared plus a 4x plus a 3. So this third degree polynomial function, I was able to find a factor. I factored that out, and with that factoring process in synthetic division, I was able to determine what the trinomial that goes along with that factor is. So what do we do from here? Well, let's see. If the second degree polynomial factors, we have tools to solve a second degree polynomial and find its roots. So let's just see if it factors first before we get to the quadratic. And it looks like it does factor to x plus 3 and x plus 1. So I was able to take this third degree polynomial function, look for all the possible rational zeros, test them all through synthetic division until I found one that had a remainder of 0. That was a target. That meant the choice I chose right there was indeed a factor, or I can use it to create a factor. It was a solution. Once I find a solution, I can rewrite my function in terms of that one factor and its resulting factor, and then start the process again. Finally got to where now I have my function as a list of products. And so I know for this to be true, x has to equal either x equals 2, -1, and -3. There are my solutions to this third degree polynomial function. Kind of a straightforward process, but it will take some practice. And it's going to take practice remembering the skills that we've learned to date so far, because we're building on those. I noticed one other thing that maybe you've noticed too. When we looked at these solutions, did you also notice that these solutions were also part of our original list of possible rational solutions? 2 is in here, -1 is in there, and -3 was in there as well. So maybe when you were doing this at home, you didn't choose 2. Maybe you chose -1 as an option to choose. You would have gotten that to be a factor, and then you could use that factor to create this next step. So I just happened to find 2 as the first one. You may have found one of the other ones as your first factor, and that was your first step to continue solving this problem.